Our map of the solar system has never been final. For generations, we believed it ended with the clockwork orbits of the classical planets, with Saturn's majestic rings marking a distant golden border. Then our reach extended, revealing Uranus and Neptune, pale blue gas giants haunting the cold outer darkness. We drew the line there, but the map had to be redrawn again. Beyond Neptune, we discovered a new realm, a vast scattered band of frozen bodies known as the Kuiper Belt. This was a logical frontier, a cosmic junkyard of icy leftovers from planetary formation, a chaotic fringe populated by dwarf worlds like Pluto. It felt right. It felt like the final messy edge of our sun's creation, the natural place for the solar system to simply end. But the universe rarely adheres to our sense of order. The clues that this was not the final edge were already known. They had been appearing in our skies for all of human history, silent visitors from a place far beyond our maps. They were the long-period comets. Unlike their short-period cousins which orbit in the same flat plane as the planets, these celestial ghosts behaved strangely. They fell toward the sun from every conceivable direction, from high above the ecliptic plane. From far below, they plunged into our system on orbits so vast, so stretched, that a single journey around the sun could take hundreds of thousands, or even millions of years. Their paths were not the organized loops of bodies born from a disk. They were the random, chaotic trajectories of objects falling from the walls of a sphere. This was the great anomaly, a profound mystery that hinted at a structure of unimaginable scale, one that had to completely envelop us. It was the Dutch astronomer, Jan Oort, who assembled these clues into one of the most staggering hypotheses in the history of science. He proposed that the Kuiper Belt was not the end. It was merely the beginning of the true outer depths. He theorized the existence of a colossal, spherical shell of icy worlds, a halo of cosmic debris surrounding the entire solar system. This structure, now known as the Oort Cloud, is not a place you can visit. It is a volume of space. Its inner boundary is thought to begin at least 2,000 times farther from the Sun than the Earth, and it may extend outwards for light years, stretching nearly a quarter of the way to the nearest star system, Proxima Centauri. The numbers are so large they become abstract. A beam of light from our Sun takes over 8 hours to reach Neptune. That same light would take nearly a year and a half just to cross the full breadth of the Oort Cloud. It is a structure composed of perhaps 1 trillion individual objects, each one a frozen worldlet of rock and primordial ice, separated from its neighbors by millions of kilometers of silent, empty dark. We have never photographed it. We have only inferred its existence from the ghostly messengers it sends our way. It is the great unseen wall around our world. Here, at this immense and invisible boundary, the very definition of our reality begins to collapse. To be within the Oort Cloud is to be in a place where the sun is no longer a life-giving star. It is a mere point of light, the brightest in the sky, but offering no discernible warmth. Its gravity, the force that holds planets in their paths and defines our entire system, becomes a whisper, an ancient, tenuous tether stretched to its absolute breaking point. This is the realm where the sun's dominion ceases to be absolute. The gravitational pull of the wider Milky Way galaxy, the tidal forces from passing stars, these distant cosmic influences become rivals to the sun's own grip. An object here is not truly in the solar system. It is balanced on the knife's edge between our sun's family and the vast cold emptiness of interstellar space. This is not just a change in distance, it is a fundamental change in the governing forces of existence. It is the edge of our sun's reality, the last known shore before the ocean of the galaxy truly begins. It is the border between being somewhere and being nowhere. The existence of this colossal theoretical shell forces upon us a profound question. If this is the physical boundary of our home, the final frontier of the sun's influence, then what does it represent? Is it merely a passive graveyard of primordial debris, a silent monument to the birth of our solar system? Or is it something more? Is it an active barrier, a membrane that separates us from the galaxy for a reason? What secrets, what ancient materials, and what other forces might be at play in this realm of near absolute cold and darkness? The comets it sends us are clues, but they are whispers from a place we cannot see. To understand the Oort Cloud is to attempt to understand the very nature of our isolation in the cosmos, and what might lie waiting just beyond the edge of our own reality. Our conception of home has always been defined by its borders, and for centuries the map of our solar system seemed comprehensible, its edges drawn by the steady clockwork paths of the planets. We charted the scorched, airless rock of Mercury, the suffocating, hellish veil of Venus, and the frozen red deserts of Mars. We pushed past the great divide of the asteroid belt and into the dominion of giants. Jupiter, a colossal ball of swirling hydrogen so vast it could swallow every other planet whole, its great red spot, a storm that has raged for centuries. And Saturn, a golden world adorned with a system of rings so elegant and complex, they appeared to be an impossible celestial jewel. For a long time this was the family. We drew the line at these distant titans. Then, with painstaking observation, our reach extended, revealing the pale, ghostly orbs of Uranus and Neptune, ice giants haunting the frigid outer darkness, where the sun's warmth is a distant memory. This, we thought, must surely be the end, and beyond them we found a third realm, a vast scattered band of frozen bodies we named the Kuiper Belt. It was a logical frontier, a cosmic debris field, a chaotic fringe populated by countless dwarf worlds like Pluto, Eris, and the elongated, rapidly spinning Haumea. This place felt like the final messy shoreline of our sun's creation, a natural boundary where the gravitational coherence of the solar system simply dissolves into the void. It should have been the end of the story. But the universe rarely provides such simple conclusions. The most profound clues that our map was still incomplete were not found by pushing our telescopes further into the dark. They were found by studying the visitors who came to us. For all of recorded history, we have watched them arrive, comets, ghosts of ice and rock, appearing suddenly in our skies, their magnificent tails of gas and dust stretching across the constellations. Some, like Halley's Comet, were predictable, their orbits understood. They were part of the system, belonging to the flat, disk-like plane of the planets. But others were profoundly different. The long-period comets were the true outliers. These celestial wanderers would plunge into the inner solar system, on orbits so immense, so radically stretched, that a single journey around the sun could take them hundreds of thousands, or even millions of years. Their composition was pristine, unblemished by the repeated solar encounters that wear down other comets, suggesting they spend nearly their entire existence in a state of deep primordial freeze. And most strangely of all, they did not obey the rules of the disk. They arrived from every conceivable direction, from high above the system's plane, from far below it, from angles that were utterly random and chaotic. They were not members of the planetary family. They were falling from the walls of some unseen colossal sphere. This was the great anomaly, a profound mystery that pointed toward a structure so vast and so all-encompassing that it must hold our entire solar system within its grasp. It was the Dutch astronomer Jan Oort who finally gave this phantom a name and a scale. In the mid-20th century, he synthesized the evidence from these cometary orbits into one of the most staggering and audacious hypotheses in the history of astronomy. He proposed that the Kuiper Belt was not a final shoreline. It was merely a shallow coastal region before the true deep ocean. He theorized the existence of a colossal spherical shell of icy worlds, a halo of cosmic debris that completely encases our solar system. This structure, the Oort Cloud, is not a cloud in any earthly sense. It is a near-perfect vacuum, a volume of space so immense it becomes an abstraction. Its inner boundary is thought to lie no closer than 2,000 times the distance from the Earth to the Sun, and it may extend outwards for light years, a vast, dark empire stretching nearly a quarter of the way to our nearest stellar neighbour, Proxima Centauri. To picture its scale, if the entire solar system out to the orbit of Neptune were the size of a coin in your hand, the Oort Cloud would be a bubble the size of a city, with its outer edge miles away in every direction. It is thought to contain not millions, not billions, but perhaps trillions of individual objects, each a frozen worldlet of rock and primordial ice, separated from its cosmic neighbours by distances greater than the space between Mars and the Earth. We have never photographed it. We have never directly detected a single one of its resident objects in their native orbits. It is a ghost, a structure inferred only by the few stray crumbs it occasionally drops into our world. It is the great, unseen wall of our solar system. It is here, at this immense and invisible boundary, that our very definition of reality begins to disintegrate. To be within the Oort Cloud is to exist in a place where the sun is no longer a life-giving star, no longer the center of existence. It has been demoted. It is just another bright point of light in a star-dusted canopy, offering no discernible warmth, no energy, no hope of day. Its gravity, the force that forges planets and dictates the dance of our entire system, is here just a whisper, a tenuous, ancient thread of influence stretched to its absolute breaking point. This is the great gravitational watershed. It is the line where an object's allegiance shifts from the Sun to the galaxy itself. The subtle tidal forces of the Milky Way, a gentle, persistent pull from the combined mass of billions of distant stars and dark matter, becomes a genuine competitor to the Sun's own grip. The slightest nudge from a passing star, millions of years in the future, can sever that final thread, casting an Oort Cloud object adrift into the interstellar void, a lost child of our Sun that will never return. This is not just a change of location, it is a fundamental change in the governing physics of an object's existence. It is the edge of our solar identity, the last bastion of material born from our home nebula. Beyond it lies the truly alien, the realm of matter from other stars, other histories. This cloud is the line between being solar and being interstellar. It is the edge of the Sun's reality. The confirmed existence of this colossal, theoretical shell would therefore force upon us a profound re-evaluation of our place in the cosmos. It becomes the ultimate question mark hanging over our world. If this is the physical boundary of our home, the final frontier of the Sun's fading influence, then what is its purpose? Is it merely a passive graveyard of primordial debris, a silent, frozen monument to the violent birth of our solar system, holding the chemical blueprints of our own origins? Or is it something more active? Could it function as a shield, a protective membrane that filters the galactic environment, absorbing cosmic rays or interstellar dust before they reach the inner planets? Could it be a cage, a natural barrier so vast and difficult to cross that it effectively isolates us and any life that may exist here from the rest of the galaxy? The comets it sends are our only clues, but they are whispers from a place we cannot see, messages in a bottle from an ocean of unimaginable size. To seek to understand the Oort Cloud is to attempt to understand the very nature of our cosmic isolation, and to confront the question of what might lie waiting for us just beyond the edge of everything we have ever known as real. Our conception of home has always been defined by its borders, and for centuries, the map of our solar system seemed comprehensible, its edges drawn by the steady clockwork paths of the planets. We charted the scorched, airless rock of Mercury, the suffocating, hellish veil of Venus, and the frozen red deserts of Mars. We pushed past the great divide of the asteroid belt and into the dominion of giants. Jupiter, a colossal ball of swirling hydrogen, so vast it could swallow every other planet whole, its great red spot, a storm that has raged for centuries. And Saturn, a golden world adorned with a system of rings so elegant and complex, they appeared to be an impossible celestial jewel. For a long time, this was the family. We drew the line at these distant titans. Then, with painstaking observation, our reach extended, revealing the pale, ghostly orbs of Uranus and Neptune, ice giants haunting the frigid outer darkness where the sun's warmth is a distant memory. This, we thought, must surely be the end, and beyond them we found a third realm, a vast scattered band of frozen bodies we named the Kuiper Belt. It was a logical frontier, a cosmic debris field, a chaotic fringe populated by countless dwarf worlds like Pluto, Eris, and the elongated, rapidly spinning Haumea. This place felt like the final messy shoreline of our sun's creation, a natural boundary where the gravitational coherence of the solar system simply dissolves into the void. It should have been the end of the story, but the universe rarely provides such simple conclusions. The most profound clues that our map was still incomplete were not found by pushing our telescopes further into the dark. They were found by studying the visitors who came to us. For all of recorded history, we have watched them arrive, comets, ghosts of ice and rock, appearing suddenly in our skies, their magnificent tails of gas and dust stretching across the constellations. Some, like Halley's comet, were predictable, their orbits understood. They were part of the system, belonging to the flat, disk-like plane of the planets. But others were profoundly different. The long-period comets were the true outliers. These celestial wanderers would plunge into the inner solar system on orbits so immense, so radically stretched, that a single journey around the sun could take them hundreds of thousands or even millions of years. Their composition was pristine, unblemished by the repeated solar encounters that wear down other comets, suggesting they spend nearly their entire existence in a state of deep, primordial freeze. And most strangely of all, they did not obey the rules of the disk. They arrived from every conceivable direction, from high above the system's plane, from far below it, from angles that were utterly random and chaotic. They were not members of the planetary family. They were falling from the walls of some unseen colossal sphere. This was the great anomaly, a profound mystery that pointed toward a structure so vast and so all-encompassing that it must hold our entire solar system within its grasp. It was the Dutch astronomer Jan Albert who finally gave this phantom a name and a scale. In the mid-20th century, he synthesized the evidence from these cometary orbits into one of the most staggering and audacious hypotheses in the history of astronomy. He proposed that the Kuiper Belt was not a final shoreline. It was merely a shallow coastal region before the true deep ocean. He theorized the existence of a colossal spherical shell of icy worlds, a halo of cosmic debris that completely encases our solar system. This structure, the Oort Cloud, is not a cloud in any earthly sense. It is a near-perfect vacuum. A volume of space so immense it becomes an abstraction. Its inner boundary is thought to lie no closer than 2,000 times the distance from the Earth to the Sun, and it may extend outwards for light years. a vast dark empire stretching nearly a quarter of the way to our nearest stellar neighbour, Proxima Centauri. To picture its scale, if the entire solar system out to the orbit of Neptune were the size of a coin in your hand, the Oort Cloud would be a bubble the size of a city, with its outer edge miles away in every direction. It is thought to contain not millions, not billions, but perhaps trillions of individual objects, each a frozen worldlet of rock and primordial ice, separated from its cosmic neighbours by distances greater than the space between Mars and the Earth. We have never photographed it. We have never directly detected a single one of its resident objects in their native orbits. It is a ghost, a structure inferred only by the few stray crumbs it occasionally drops into our world. It is the great, unseen wall of our solar system. It is here, at this immense and invisible boundary, that our very definition of reality begins to disintegrate. To be within the Oort Cloud is to exist in a place where the sun is no longer a life-giving star, no longer the centre of existence. It has been demoted. It is just another bright point of light in a star-dusted canopy, offering no discernible warmth, no energy, no hope of day. Its gravity, the force that forges planets and dictates the dance of our entire system, is here just a whisper, a tenuous, ancient thread of influence stretched to its absolute breaking point. This is the great gravitational watershed. It is the line where an object's allegiance shifts from the sun to the galaxy itself. The subtle tidal forces of the Milky Way, a gentle, persistent pull from the combined mass of billions of distant stars and dark matter, becomes a genuine competitor to the sun's own grip. The slightest nudge from a passing star, millions of years in the future, can sever that final thread, casting an Oort Cloud object adrift into the interstellar void, a lost child of our sun that will never return. This is not just a change of location. It is a fundamental change in the governing physics of an object's existence. It is the edge of our solar identity, the last bastion of material born from our home nebula. Beyond it lies the truly alien, the realm of matter from other stars, other histories. This cloud is the line between being solar and being interstellar. It is the edge of the sun's reality. The confirmed existence of this colossal theoretical shell would therefore force upon us a profound re-evaluation of our place in the cosmos. It becomes the ultimate question mark hanging over our world. If this is the physical boundary of our home, the final frontier of the sun's fading influence, then what is its purpose? Is it merely a passive graveyard of primordial debris, a silent, frozen monument to the violent birth of our solar system, holding the chemical blueprints of our own origins? Or is it something more active? Could it function as a shield, a protective membrane that filters the galactic environment, absorbing cosmic rays or interstellar dust before they reach the inner planets? Could it be a cage, a natural barrier so vast and difficult to cross that it effectively isolates us and any life that may exist here from the rest of the galaxy? The comets it sends are our only clues, but they are whispers from a place we cannot see, messages in a bottle from an ocean of unimaginable size. To seek to understand the Oort Cloud is to attempt to understand the very nature of our cosmic isolation, and to confront the question of what might lie waiting for us just beyond the edge of everything we have ever known as real. To comprehend a structure as vast and ephemeral as the Oort Cloud, we must first journey back in time, back to the very birth of our solar system, a period of unimaginable violence and cosmic chaos that stands in stark contrast to the perfect, silent stillness where the cloud now resides. The early solar system was not the orderly, predictable clockwork we see today. It was a cosmic construction site, a swirling, incandescent disk of gas and dust, left over from the formation of the sun itself. Within this protoplanetary disk, gravity began its patient, relentless work. Dust grains clung together, forming pebbles. Pebbles collided to form rocks. Rocks crashed together to become planetimals, the small primordial bodies that served as the building blocks for worlds. For millions of years, this process of accretion was a brutal ballet of creation and destruction. Countless aspiring planets were shattered by collisions, their fragments absorbed into the growing giants that would come to dominate the system. Our own Earth was formed in this crucible, likely suffering a cataclysmic impact with a Mars-sized body that created our moon. This was the universal story of our neighborhood, a story of gravitational dominance where the strong consumed the weak. But not everything found a home. The true architects of the Oort Cloud were the great gas giants, Jupiter and Saturn. As these colossal worlds grew, their gravitational influence became immense, a dominant force that shaped the fate of every smaller object in their vicinity. They became the bouncers of the solar system. Their powerful gravity wells acted as colossal slingshots, capturing the trillions of leftover icy planetimals and flinging them with incredible force. The majority of these frozen relics were ejected from the solar system entirely, cast out into the great interstellar void to wander between the stars for eternity as rogue objects. But a significant fraction of them did not achieve full escape velocity. They were thrown with tremendous energy, but not quite enough to break the sun's final, most tenuous gravitational grip. These objects were lofted into enormously elongated, eccentric orbits, their paths taking them thousands or tens of thousands of times farther from the sun than the Earth. They sailed outwards for millions of years into the cold and the dark, slowed by the sun's fading pull, before beginning the long, slow fall back inwards. This was the Great Expulsion, the violent seeding of the outer darkness with the pristine frozen remnants of the sun's own birth nebula. Yet, this initial scattering does not fully explain the structure we theorize today. The chaotic flinging of objects from the planetary disk would have created a messy, disorganized collection of bodies on wildly different paths. It would not by itself create a stable, spherical shell. The final, elegant architecture of the Oort Cloud was sculpted not by a single act of violence but by billions of years of slow, patient, cosmic influence. The first of these sculptors is the galaxy itself. As our solar system orbits the center of the Milky Way, it is subjected to the galaxy's subtle tidal forces, this gentle, persistent gravitational stretching caused by the combined mass of all the stars and dark matter in the galaxy. Worked on the loosely bound orbits of these distant objects, it randomized them, pulling them, torquing them, lifting them out of their original orbital planes. Over the eons, this galactic tide erased their memory of the flat disk they were born in, puffing up their collective paths into the vast spherical shape we now envision. The second sculptor came in the form of other stars. On its long journey through the galaxy, our Sun has passed relatively close to countless other stellar systems. Each time another star swept by, even at a distance of a light year or two, its gravity would have tugged and perturbed the fragile outer layers of this nascent cloud, further stirring and randomizing the orbits within. The Oort Cloud is therefore not just a product of our solar system. It is a structure born from a conversation between our Sun and the galaxy itself. Modern theories suggest this cosmic halo is not one uniform structure, but is likely composed of two distinct regions. The most famous part is the outer Oort Cloud, the vast spherical shell we have been describing, beginning perhaps 20,000 astronomical units from the Sun and stretching outwards. This is the region most weakly bound to the Sun, and the one most susceptible to the gravitational nudges of passing stars and galactic tides. It is from this dynamic, fragile outer layer that most of the long-period comets we observe are thought to originate. But hidden within it, there may be a second, much denser region known as the Hills Cloud, named for the astronomer Jack Hills who proposed its existence. This inner Oort cloud is theorized to be more of a thick, flattened disk or torus, starting only a few thousand astronomical units out and holding vastly more material, perhaps 10 to 100 times the mass of the outer sphere. The bodies in the Hills cloud are more tightly bound to the Sun and are therefore far more stable. They are not so easily dislodged. This inner region acts as the Great Quiet Reservoir, a deep freeze storage tank that remains largely undisturbed, but which, over billions of years, slowly replenishes the outer Oort cloud as its own members are stripped away by galactic forces or sent plunging toward the Sun. This two-tiered structure provides a more complete and resilient model, explaining how the Oort cloud can continue to exist and produce comets even after billions of years of attrition. But more importantly, the origin and structure of the Oort cloud define its ultimate scientific value. It is a cosmic time capsule. The objects within it are not just rocks and ice. They are the most pristine, unaltered material available from the dawn of the solar system. While the planets were melted, reformed, and battered by eons of geology and radiation, the contents of the Oort cloud have been in a state of near-perfect preservation, locked in a freezer at temperatures just a few degrees above absolute zero. They are the leftover building blocks, the chemical ingredients from the primordial solar nebula that never made it into a planet. They contain a frozen, untarnished record of the conditions, the elements, and the chemistry that existed right before our world, and every other world in our system, was born. To study a sample from the Oort cloud would be to read the first page in our solar system's baby book. It would be to touch a ghost of our own creation. So the cloud is not merely a boundary, it is our attic, a dark, cold, and impossibly distant storage space, filled with the forgotten artifacts of our own genesis. It holds the chemical clues to the water in our oceans, and perhaps even the organic molecules that eventually led to life on Earth. But if this vast, silent repository holds the keys to our past, it also presents a potential threat to our future. Its stability is not absolute. The same galactic forces that sculpted it continue to act upon it, and there may be other, more aggressive forces capable of stirring its depths. What would happen if something were to seriously disturb this delicate balance? What dangers could be unleashed if a celestial vandal were to pass through this ghostly nursery, knocking its frozen children from their cradles and sending them falling into our home? The ghost of our creation could, under the right circumstances, become the herald of our destruction. To truly grasp the nature of a structure as phantasmal and vast as the Oort cloud, we must rewind the cosmic clock by 4.5 billion years. We must journey back to the genesis of our solar system, an era of such breathtaking violence and chaotic energy that it defies the serene, predictable order of the heavens we know today. In the place of stable planetary orbits was a swirling, incandescent maelstrom of gas and dust, a protoplanetary disk encircling a young, volatile sun. In the fiery inner regions of this disk, gravity began its patient work, pulling together particles of dust to form rocks, while in the frigid outer reaches where temperatures plummeted, particles of ice did the same. This was the dawn of accretion, a gravitational snowball effect on a system-wide scale. For millions of years, the solar system was a cosmic demolition derby. Hundreds, perhaps thousands of protoplanets battled for orbital dominance, their paths crossing in a brutal ballet of creation and destruction. Worlds were shattered, their cores exposed, their fragments consumed by larger growing rivals. Our own Earth was forged in this crucible, and the evidence of this violence is our own moon, believed to be the result of a cataclysmic planet-shattering impact. This was the law of the young solar system, a ruthless gravitational sorting where only the largest and most stable bodies would ultimately survive. But survival did not mean every piece of debris found a permanent home. The final grand architecture of the outer solar system was dictated by its newly crowned kings, the gas giants Jupiter and Saturn. As these colossal worlds swept up gas and dust, their gravitational influence swelled to tyrannical proportions, allowing them to shape the fate of every smaller object that strayed into their path. They became the great gatekeepers of the solar system. Their gravity wells acted as unimaginably powerful slingshots. The trillions of leftover icy planesimals, primordial worldlets that had failed to coalesce into larger planets, were captured and flung with ferocious energy. Each tiny body, as it passed close to a giant like Jupiter, stole an infinitesimal amount of the planet's immense orbital energy, converting it into its own velocity. The vast majority were ejected completely, flung out of the solar system with such force that they broke free from the sun's gravity forever, destined to wander the interstellar void as solitary rogue objects. But a significant fraction, untold billions of them, were thrown onto trajectories that were stupendously energetic, yet not quite powerful enough to escape. They were lofted into enormously elongated, highly eccentric orbits, sailing outwards for millions of years into the absolute cold and darkness, slowing to a near standstill at their farthest point before beginning the long, silent fall back towards the star that birthed them. This was the Great Expulsion, a violent, chaotic seeding of the outer darkness with the pristine, frozen rubble of the sun's own creation. Yet, even this system-wide expulsion does not fully account for the serene spherical structure we theorize today. The initial scattering would have created a disorganized, flattened swarm of bodies, their orbits still largely reflecting the plane of the disk they came from. The final, elegant architecture of the Oort Cloud was sculpted over the subsequent 4 billion years by forces both patient and profound. The primary sculptor was the Milky Way galaxy itself, as our solar system embarks on its 225 million-year orbit around the galactic center. It is constantly bathed in the galaxy's subtle tidal forces, this gentle, persistent gravitational shear caused by the combined mass of the galaxy's stars, gas, and dark matter, stretched and torqued the loose, distant orbits of these icy bodies. It pulled on them, lifted them, and gradually randomized their inclinations, erasing their collective memory of the flat disk they were born in. Over the eons, this tireless cosmic tide puffed up their orbits into the vast spherical shape we now envision. This process was aided by a second sculpting force, the passage of other stars. On its long journey, our Sun has drifted past countless other stellar systems. About 70,000 years ago, a small binary star system known as Scholz's star is believed to have passed directly through the outer edges of the cloud. Each such stellar encounter, even at a tranquil distance of a light year, sends a gentle gravitational ripple through the cloud, further stirring and randomizing the orbits of its most fragile, loosely held members. The Oort Cloud is therefore not a monument to our Sun alone. It is a shared creation, a structure born from a 4 billion year conversation between our solar system and the grander architecture of the galaxy. Modern theoretical models, refined by increasingly powerful simulations, suggest this cosmic halo is not a single uniform entity. It is believed to be composed of two distinct, nested regions, each with its own character and purpose. The most renowned section is the outer Oort Cloud, the vast, near-perfect spherical shell that represents the system's final frontier, beginning perhaps 20,000 astronomical units from the Sun. This is the dynamic, active surface of the cloud, a region where its objects are so weakly bound to the Sun that they are in a constant state of flux, susceptible to the slightest gravitational nudges from the galaxy. It is from this fragile outer layer that the majority of the spectacular long-period comets we witness are believed to originate. But hidden deep within it, like the dense yolk within an enormous egg, is believed to be the Hills Cloud. This inner Oort Cloud is theorized to be a much more massive and substantial structure, likely shaped like a thick, flattened donut or torus. It may begin only a few thousand astronomical units from the Sun, and could contain up to 90% of the Oort Cloud's total mass. Its objects are far more tightly bound by the Sun's gravity, making them incredibly stable. This inner region is the Great Silent Reservoir, a deep-freeze storage depot that remains largely placid and undisturbed, but which over the eons serves to slowly bleed objects outward, replenishing the outer Oort Cloud as its own members are stripped away by the galaxy, or sent plunging toward the Sun. This elegant two-tiered structure provides a more complete and resilient model for the outer solar system, but more profoundly, the cloud's origin story defines its ultimate scientific importance. It is, without exaggeration, a cosmic time capsule. The trillions of bodies suspended within it are not merely inert rocks and ice. They are the most pristine, unaltered samples of the primordial solar nebula known to exist. While the matter that formed the planets was melted, compressed, irradiated, and battered by 4.5 billion years of violent geology, the contents of the Oort Cloud have been in a state of near-perfect preservation, locked in a cryogenic freezer at temperatures just a few degrees above absolute zero. They are the leftover bricks and mortar of creation. They hold a frozen, untarnished record of the exact chemical conditions that existed in our corner of the galaxy moments before the Earth, and every world we know was born. To analyze a fragment from the Oort Cloud would be to read a lost page from our own origin story. It could contain pre-solar grains, stardust forged in the hearts of other long-dead stars, and the very same organic molecules and water ice that, when delivered to the young Earth by comets, may have provided the essential ingredients for life. Thus, the Oort Cloud is not simply a boundary, it is our system's celestial attic, a dark, impossibly remote archive filled with the forgotten relics of our own genesis. It holds the chemical keys to our past, and by extension, our very existence. Yet, if this silent, frozen repository is a library of our history, its very nature also makes it a potential arsenal aimed at our future. Its stability is a delicate, dynamic equilibrium, not a permanent state. The same galactic forces that sculpted it continue to tug at it. And there may be other, more disruptive forces lurking in the darkness, capable of violently stirring its serene depths. What would happen if a hidden hand were to pass through this ghostly nursery, knocking its trillions of frozen children from their ancient cradles? What secrets might be unlocked, or what unimaginable dangers could be unleashed if something were to wake the sleeping giants of the long cold dark? The ghost of our creation could, under the right circumstances, become the herald of our destruction. The Oort Cloud, in its profound stillness, presents a paradox. It is both a monument to stability, having persisted for billions of years, and a reservoir of unimaginable kinetic energy, holding trillions of frozen worlds in a state of delicate gravitational balance. We have established its origin as a ghost of our creation, but this understanding only deepens the mystery of its present behavior. The long-period comets that fall from its depths are proof that this balance is not perfect. Something occasionally stirs this sleeping giant, and the question then shifts from how the cloud was formed to what is shaking it now. The search for an answer has led astronomers to consider possibilities that sound like mythology: hidden worlds, lost siblings of the Sun, and vast unseen mechanisms that tie our fate to the rhythm of the galaxy. We are no longer just mapping a structure. We are searching for the hidden hand that sometimes sends its contents tumbling into our home. In recent years, the most compelling evidence for a hidden influence has emerged not from the Oort Cloud itself, but from the Kuiper Belt, the icy ring of debris just beyond Neptune. Astronomers noticed a baffling anomaly. A small exclusive club of the most distant known objects in the solar system were all following bizarre, harmonized orbits. Their elongated paths were all tilted in the same direction, and they all clustered together in one quadrant of the sky, as if being herded by an unseen celestial shepherd. Such an arrangement is statistically almost impossible to be a coincidence. It is the gravitational signature of something enormous, lurking unseen in the profound darkness of the outer solar system. This has given rise to the leading hypothesis for a modern agitator, Planet 9, theorized by astronomers Konstantin Batygin and Mike Brown. This would be a true ninth planet, not a dwarf like Pluto, but a genuine giant. It is predicted to be a world perhaps 5 to 10 times the mass of Earth, a super-Earth or a mini-Neptune, on a vast, eccentric and highly inclined orbit that takes it on a journey of 10 to 20,000 years. Its immense distance and the faintness of the sunlight it reflects would make it incredibly difficult to detect with current telescopes. This hidden world, if it exists, would not only explain the strange clustering of the Kuiper Belt objects, but its vast orbit would act as a colossal, slow-moving stirring stick, one that could gravitationally interact with the innermost regions of the Oort Cloud, the dense hills cloud. Over its long, lonely journey, Planet 9 would periodically sweep through this reservoir of comets, its gravity dislodging them from their stable orbits and initiating their million-year fall toward the Sun, providing a constant, steady trickle of new long-period comets into our skies. But there is another, older, and far more dramatic hypothesis, born not from the orbits of distant rocks, but from the record of life and death written in the fossils of our own planet. In the 1980s, paleontologists examining the fossil record discovered what appeared to be a terrifying pattern. Mass extinctions, the great die-offs that periodically reset the course of evolution on Earth, did not seem to be random. They appeared to occur in a stunningly regular cycle, roughly every 26 to 30 million years. This ghostly pulse of destruction hinted at a cosmic cause, a trigger of immense and predictable power. To explain it, scientists proposed a truly radical idea, nemesis. The hypothesis suggests that our Sun is not alone, that it has a hidden, long-lost companion, a dark twin on an immense looping orbit, far beyond any of the known planets. This companion would likely be a small, incredibly dim red dwarf star, or perhaps a brown dwarf, a failed star that never gathered enough mass to ignite nuclear fusion. Its orbit would be so vast that it would take 26 million years to complete. For most of that time, it would be an invisible wanderer in the interstellar dark, but at its closest approach to our Sun, its path would carry it directly through the densest parts of the Oort Cloud. Each passage would be a cataclysmic event. Nemesis's gravity would act like a gravitational rake, tearing through the cloud and unleashing a devastating storm of billions of comets into the inner solar system. For thousands of years, the skies of Earth would be filled with these falling stars, and the probability of a catastrophic impact or multiple impacts would increase 1,000-fold. This comet shower would perfectly explain the cyclical nature of mass extinctions. Despite decades of searching, however, extensive infrared sky surveys have failed to find any evidence of such a companion, and the Nemesis hypothesis, while compellingly elegant, has largely fallen out of favor with the mainstream scientific community. These two grand theories, Planet 9 and Nemesis represent two very different kinds of potential agitators. Planet 9 is a member of the family, a sibling planet, whose influence is more localized, more constant and more subtle, primarily shaping the architecture of the Kuiper Belt and gently stirring the inner edge of the Oort Cloud. Nemesis is a foreign invader, a long-lost cousin, whose influence is periodic, system-wide, and utterly catastrophic, a true agent of doom whose return is tied to the rhythm of death on Earth. While they seem mutually exclusive, the vastness of the outer solar system leaves room for speculation. Could some version of both be true? Could a Planet 9 on a much longer, more eccentric orbit than currently predicted be the true cause of the extinction cycle, acting as a less dramatic but still effective nemesis? Or are they simply two different attempts to explain separate phenomena, one gravitational and observable in the orbits of today's asteroids, the other biological and buried deep in Earth's geological past? The puzzle of the outer solar system is that there may be more than one hidden mechanism at play, each operating on different scales of time and distance, each leaving its own unique and ghostly fingerprint on the worlds within. There is, however, a third possibility, one that does not require a hidden object at all. It suggests the periodic disturbances are not caused by a member of our solar system, but by our solar system's journey through the galaxy itself. This is the foundation of the Shiva hypothesis. It posits that the cyclical extinctions are triggered by our solar system's regular passage through the dense, star-filled plane of the Milky Way galaxy. Our Sun's orbit is not flat. It oscillates up and down through the galactic disk, much like a horse on a carousel. The period of this oscillation is roughly 30 million years, eerily close to the timing of the extinction cycle. Each time our solar system plunges through the dense central plane, it would be subjected to a host of gravitational perturbations from the higher concentration of stars, gas clouds, and even dark matter. These increased tidal forces would be more than enough to violently disturb the fragile outer Oort Cloud, triggering the same kind of devastating comet showers predicted in the Nemesis theory. In this scenario, the agent of chaos is not a dark star, but the very structure of our home galaxy. The Oort Cloud becomes a sensitive membrane, a cosmic barometer that registers our passage through different galactic neighborhoods, and the record of those passages is written in stone and bone here on Earth. Whether the threat is an unseen planet, a dark stellar twin, or the rhythmic pulse of the galaxy itself, the implication is the same. The Oort Cloud is not a static, disconnected museum piece. It is a loaded weapon, aimed inward. It is a vast, sensitive network that connects the deepest history of our planet to the grand, hidden mechanisms of the cosmos. The evidence for these mechanisms is faint, buried in the statistical noise of asteroid orbits or the fragmented history of ancient life. But the clues are there. They suggest that the long, quiet periods of stability we enjoy are periodically, and perhaps predictably, interrupted by waves of destruction originating from this farthest, darkest frontier. If these immense, slow-moving threats are indeed real, how would we ever prove their existence beyond a shadow of a doubt? What are the specific, tangible breadcrumbs they might leave behind for us to find? And have we, perhaps, already found them without fully realizing what they mean? The Oort Cloud, in its profound and silent majesty, presents a deep paradox. It is simultaneously a monument to near-perfect stability, having persisted at the edge of our solar system for over 4 billion years, and a reservoir of unimaginable potential energy, a gravitational pane of glass holding trillions of frozen worlds in a state of delicate, precarious balance. We have established its origin as a ghost of our creation, a relic of the violent dawn of our sun, but this understanding only serves to deepen the mystery of its present behavior. The long-period comets that occasionally fall from its depths are incontrovertible proof that this balance is not absolute. Something from time to time stirs this sleeping giant. The question then evolves, moving from the scientific what and how of the cloud's formation into the speculative, unsettling realm of what if. We are no longer just mapping a static structure. We are searching for the hidden hand, the unseen agent, the cosmic agitator that sometimes reaches into this celestial attic and sends its contents tumbling down upon the worlds below. In recent decades, the most compelling evidence for such a hidden influence has emerged not from the distant Oort Cloud itself, but from the dark, frozen plains of the Kuiper Belt, just beyond the orbit of Neptune. Astronomers, while tracking the most extreme objects known in our solar system, discovered a baffling and statistically impossible anomaly. A small, exclusive club of icy bodies, including distant worlds like Sedna and the object nicknamed the Goblin, were all following bizarre, harmonized orbits. Their vastly elongated paths were all tilted at a similar angle relative to the rest of the solar system, and their closest approaches to the Sun were all clustered together in one quadrant of the sky. They moved as if being herded by an unseen gravitational shepherd. To explain this extraordinary coincidence, astronomers Konstantin Batygin and Mike Brown proposed a bold solution: Planet 9. They theorized the existence of a true massive ninth planet, not a dwarf like Pluto but a genuine giant, a super-Earth or mini-Neptune, perhaps 5 to 10 times the mass of our own world. This planet would be on a vast, eccentric and highly inclined orbit, taking 10 to 20,000 years to make a single journey around the Sun. At such an immense distance, it would reflect an infinitesimal amount of sunlight, making it dimmer than most of the stars it moves against, and its motion across the sky would be so slow as to be almost imperceptible. This hidden world, if it exists, would not only solve the puzzle of the clustered orbits by acting as a great, stabilizing resonant engine, but its immense orbital path would act as a colossal, slow-moving stirring stick. Its closest approach to the Sun would keep it far from the main planets, but its farthest reach could take it deep into the dense inner region of the Oort Cloud, the Hills Cloud, acting as a persistent, low-grade agitator, constantly flinging new cometary candidates into the more chaotic outer cloud, or sending them directly on their long million-year fall towards us. There is, however, another, older, and far more dramatic hypothesis, one born not from the subtle mathematics of orbital mechanics, but from the catastrophic history of life and death etched into the fossil record of our own planet. In the 1980s, paleontologists examining the history of biodiversity discovered what appeared to be a terrifyingly regular pattern: mass extinctions, the great biological crises that periodically reset the course of evolution, did not seem to be random events. They appeared to occur in a stunningly regular cycle, a ghostly pulse of destruction repeating roughly every 26 to 30 million years. This seeming cosmic clock of doom demanded a cosmic explanation, leading to a truly radical idea: nemesis. This hypothesis suggests our Sun has a secret, a hidden, long-lost companion star, a dark twin on an immense looping orbit far beyond any of the known planets. This companion would likely be an incredibly dim red dwarf star, or perhaps a brown dwarf, a failed star that never achieved the mass to ignite nuclear fusion, making it a celestial object that radiates only a faint, almost undetectable infrared heat. For millions of years it would be an invisible wanderer, but at its closest approach, its orbit would carry it directly through the dense inner Oort Cloud. Each passage would be a cataclysmic event. Nemesis's gravity would act like a gravitational scythe, tearing through the cloud and unleashing a devastating storm, a comet shower of billions of icy bodies into the inner solar system. For thousands of years, the solar system would become a cosmic shooting gallery, and the probability of a catastrophic impact on Earth would increase 1,000-fold. The hypothesis has since lost favour, as extensive infrared sky surveys like WISE have ruled out any large brown dwarf or nearby red dwarf companions. Still, the idea isn't definitively dead, merely on life support, as a sufficiently small and cold object on an extreme orbit could, in theory, still be hiding in the vast unsearched darkness. These two grand theories, Planet 9 and Nemesis, represent two profoundly different kinds of potential agitators, operating on different scales of time and consequence. Planet 9 is a resident ghost, a permanent member of our solar system's architecture that we simply overlooked. Its influence is structural, subtle, and constant, a low-level disturbance that shapes the outer system as part of its normal function. Nemesis is an external clock of doom, a mythological intruder whose only narrative purpose is to deliver periodic, overwhelming destruction from an immense distance. While one seems to explain the current structure of the Kuiper Belt and the other the ancient history of extinction on Earth, the unsettling question remains, are they mutually exclusive? Could the clustering of distant objects and the ancient extinction cycle be unrelated phenomena, meaning our solar system might be subject to both a constant stirring from within and a rare cataclysmic disturbance from without? Or could a single unseen world, a Planet 9 on a much longer and more disruptive orbit than currently modelled, be responsible for both? The outer solar system is a realm of such profound mystery that it may harbour multiple hidden mechanisms, each leaving its own ghostly fingerprint on the history of our world. There is, however, a third grand possibility, one that is perhaps the most elegant and humbling of all, as it requires no hidden objects within our system's borders. It suggests the periodic disturbances are caused by our solar system's majestic and inescapable journey through the Milky Way galaxy. This is the core of the Shiva hypothesis. It posits that the cyclical extinctions are triggered by our sun's regular oscillation up and down through the dense, star-filled plane of our galaxy. This vertical bobbing motion has a period of roughly 30 to 35 million years, eerily close to the timing of the extinction cycle. Each time our solar system plunges through the galactic plane, a veritable river of stars, gas, and gravitational turbulence, it is subjected to a dramatic increase in external perturbations. The tidal forces from the higher concentration of matter would be more than enough to violently disturb the fragile outer Oort Cloud, triggering the same devastating comet showers predicted by the Nemesis theory. In this magnificent scenario, the agent of chaos is not a dark star or an unseen planet. It is the very structure of our home galaxy. The Oort Cloud becomes a sensitive cosmic membrane, and the cycles of life and death on our small blue world are fundamentally tied to a rhythm set by the majestic and utterly indifferent turning of the Milky Way. Therefore, whether the source of the disturbance is an unseen shepherd in our own backyard, a long-lost dark twin on a destructive pilgrimage, or the very rhythm of the galactic tide, the implication for our understanding of the solar system is profound. The Oort Cloud is transformed in our minds from a passive, frozen museum of cosmic history into an active and loaded weapon, aimed perpetually inward. The stability we take for granted is not a given. It is a temporary state, an interlude between storms. The theories are grand, the implications are terrifying, but are they anything more than cosmic ghost stories, elaborate myths to explain the darkness? To answer that, we cannot simply look outward with our telescopes. We must look down into the rock beneath our feet, into the layers of sediment that hold the memory of ancient impacts, and into the great craters that scar the face of our world and others. For it is here, in the geological scars of past catastrophes, that the physical fingerprints of these hidden agitators might be found, waiting for us to finally learn how to read them. Theories as grand and terrifying as a hidden planet, a dark stellar twin, or a galactic tidal rhythm demand more than elegant mathematics and compelling narratives. To be elevated from cosmic ghost stories to credible scientific hypotheses, they must leave behind physical, verifiable evidence. If our solar system is indeed subject to periodic bombardments triggered by a hidden agitator, then the history of those events should be written into the very fabric of our world. The search for proof, therefore, must turn away from the theoretical darkness of the outer solar system and look down into the layered rock beneath our feet. For it is here in the geological strata that serve as Earth's memory, and in the great impact craters that scar its surface, that the faint fingerprints of these ancient catastrophes might still be found, waiting for the right eyes to read them. The investigation moves from the cosmos to the crime scene. The single most important piece of evidence, the veritable smoking gun for a cosmic impact causing a mass extinction, was discovered not by astronomers, but by geologists. In the late 1970s, a team led by the father and son duo, Luis and Walter Alvarez, was studying rock formations in Italy. They were examining a thin, unassuming layer of clay that marked one of the most significant moments in our planet's history, the Cretaceous-Paleogene boundary, or KT boundary. The geological horizon laid down 66 million years ago, precisely at the moment the dinosaurs, and 75% of all species on Earth, vanished. When they analysed this clay layer, they found something astonishing. It was extraordinarily rich in the element iridium. Iridium is a metal of the platinum group, and while it is relatively common in asteroids and comets, it is exceptionally rare on the surface of the Earth. During our planet's molten formation, heavy elements like iridium sank deep into the core, leaving the crust depleted. To find such a concentrated layer of it, spread uniformly all across the globe at the exact same geological moment, could mean only one thing. It was the settled soot from a colossal vaporized extraterrestrial object. This iridium-rich layer was definitive proof that a massive body from space, at least 10 kilometers in diameter, had struck the Earth and caused the very extinction event that cleared the way for the rise of mammals, and ultimately, ourselves. The discovery of the iridium layer confirmed that a cataclysmic impact had occurred, but it did not reveal where. The hunt was now on for the wound itself, a crater of immense proportions that had been hidden by the geological processes of 66 million years. The search led to the Yucatan Peninsula in Mexico. For decades, geophysicists working for the state oil company, Pemex, had noted strange semicircular gravitational anomalies beneath the surface, but their significance was not understood. It was only in the early 1990s that scientists connected these anomalies with the iridium layer and other impact evidence, such as shocked quartz and glassy tektites found across the Caribbean. They had found it. The Chicxulub crater, buried beneath a kilometer of younger sedimentary rock. This impact scar is over 180 kilometers wide and 20 kilometers deep. The energy released by its formation is almost beyond comprehension, equivalent to billions of atomic bombs detonating at once. The impact would have triggered continent-spanning wildfires, mega tsunamis miles high that scoured coastlines thousands of kilometers away, and a superheated blast of vaporized rock that would have sterilized a vast portion of the planet in minutes. Chicxulub was the confirmation. It was no longer a theory. A body from space did hit the Earth and did cause a mass extinction. The effect of a cosmic agitator was now proven. But proving a single catastrophic murder is entirely different from proving the existence of a serial killer operating on a predictable schedule. To validate the Nemesis or Shiva hypotheses, scientists needed to find evidence of a cycle of impacts, not just one. This has proven to be an immensely difficult task. Earth is a living, breathing planet. Its surface is constantly being recycled. Plate tectonics subducts old crust. Mountains rise and fall, and wind and water relentlessly erode ancient features. Unlike the Moon, the Earth quickly hides its scars. The record of impact craters is therefore woefully incomplete, heavily biased towards more recent and larger events that have managed to survive the ravages of time. Despite this, scientists have attempted to date the known impact craters to see if their ages cluster around the same 30 million year intervals as the extinction events. The results of this statistical analysis have been deeply contentious and frustratingly ambiguous. Some studies have claimed to find a faint but persistent signal of a cycle, a ghostly rhythm in the timing of impacts. Other, more recent analyses, however, have dismissed these findings as statistical artifacts, phantom patterns that emerge from an incomplete and poorly dated record. The evidence from Earth's own craters remains tantalizing but inconclusive, a whisper of a pattern that may or may not be real. To escape the geological chaos of our own world, the search for evidence has expanded to our silent celestial neighbor, the Moon, lacking an atmosphere, oceans, or plate tectonics. The Moon's surface is a pristine, perfectly preserved witness to the history of impacts in our solar system. Every major crater from the last 3 billion years is still there, a silent testament to past bombardments. By using radiometric dating on lunar samples brought back by the Apollo missions, and by counting the density of craters on different lunar surfaces, scientists can construct a more reliable timeline of the impact rate in our corner of the cosmos. This lunar record clearly shows the scars of the late heavy bombardment, an intense period of impacts early in the solar system's history. But the critical question is, what happened after that? Has the rate of impacts been relatively constant, or has it experienced periodic spikes or pulses that would align with a cyclical agitator like Nemesis, or the passage through the galactic plane? Once again, the data is subject to intense debate. Some research suggests the impact rate has been slowly increasing over the last few 100 million years, while other studies find evidence for short, sharp bursts of activity. The lunar record provides a clearer page than Earth's, but the story written upon it is still difficult to decipher with certainty. So, the investigation into the physical evidence arrives at an impasse. We possess definitive, chilling proof of singular, world-altering impacts, a confirmation that our planet is not immune to threats from the outer darkness. The Chicxulub crater is the tombstone of the dinosaurs, and a stark warning to us. Yet, the evidence for a repeating, predictable pattern, a cosmic cycle of destruction driven by a hidden hand, remains frustratingly elusive, a ghost in the statistical noise of an incomplete geological record. The scars on the Earth and the Moon tell us what can happen, but they cannot definitively tell us why it happens, or when it might happen again. If the geological record is too messy and too eroded to give us a clear answer, then the search for the agitator must change tactics. We must look for the agent itself, not just the wreckage it leaves in its wake. Our gaze must turn outward again, away from the ancient scars and back into the living, breathing darkness of the outer solar system, armed with new tools and new ways of seeing, to hunt for the shadow of a hidden world. Grand theories of cosmic disruption, whether they involve hidden planets, dark stellar twins, or the rhythmic pulse of the galaxy, must ultimately descend from the realm of abstract mathematics and into the tangible world. To be considered more than elaborate, compelling myths, they must leave behind physical evidence, indelible scars upon the solar system that can be independently verified. If our world is indeed subject to periodic bombardments triggered by a hidden hand, then the history of those violent episodes should be written into the very fabric of our planet. The investigation, therefore, must pivot. It turns from the theoretical darkness of the outer void to the layered rock beneath our feet, for it is here, in the geological strata that serve as Earth's deep memory, and in the great eroded impact craters that pockmark its surface, that the faint 66-million-year-old fingerprints of these ancient catastrophes might still be found. The search moves from the cosmos to the crime scene, a scene where the evidence has been weathered by eons and the prime suspect is a ghost. The single most crucial piece of evidence, the undeniable proof that a cosmic impact could orchestrate a global extinction, was unearthed not by astronomers gazing at the sky, but by geologists digging in the dirt. In the late 1970s, a team including Nobel laureate Luis Alvarez and his geologist son Walter Alvarez was investigating rock formations in Italy. Their initial goal was modest. They sought to determine how quickly the layers of limestone had been deposited. To do this, they decided to use the element iridium as a cosmic clock. Knowing that a fine dust of micrometeorites constantly rains down on Earth at a relatively steady rate, they theorized that measuring the concentration of iridium, an element rare on Earth's crust but common in asteroids, would tell them how much time was represented by each centimeter of rock. But when they analyzed the thin, dark line of clay that marked the Cretaceous-Paleogene or KT boundary, the geological instant when the dinosaurs and over 3/4 of all life on Earth vanished, their experiment broke. The amount of iridium was not just slightly elevated, it was hundreds of times greater than normal. It was an anomaly so extreme it could not be explained by any terrestrial process. It was the clear, unmistakable chemical signature of a colossal extraterrestrial object that had been vaporized upon impact, its alien dust settling across the entire planet like a funeral shroud. This discovery was soon replicated worldwide, from Denmark to New Zealand, proving the event was not local, but a global catastrophe of almost unimaginable scale. The iridium layer was the smoking gun, but the body of the victim, the impact crater itself, was still missing. The hunt was on for a wound of planetary proportions, a scar likely hidden by 66 million years of erosion, sedimentation, and shifting continents. The clues that led to its discovery were scattered and subtle. Geologists found strange formations of shocked quartz and tiny glass beads called spherules across the Caribbean basin, minerals and melts forged in the unimaginable pressures and temperatures of a massive impact. For decades, geophysicists working for the Mexican state oil company, Pemex, had also noted a peculiar, perfect arc of gravitational anomalies under the limestone platform of the Yucatan Peninsula, but its origin was a mystery. It was only in the early 1990s that these disparate clues were finally pieced together. The gravitational anomaly was the buried rim of a colossal crater, over 180 kilometers wide and 20 kilometers deep, centered near the town of Chicxulub. The energy released by its formation was 1,000 times greater than the entire world's nuclear arsenal detonating at once. The impact would have triggered continent-spanning wildfires, earthquakes that shook the entire planet, and megatsunamis miles high. It vaporized a thick platform of sulfur-rich rock, injecting a colossal volume of aerosols into the stratosphere that blocked out the sun, plunging the world into a dark, freezing impact winter that collapsed the entire global food chain at its foundation. Photosynthesis. Chicxulub was the visceral confirmation. An object from space did hit the Earth, and it did trigger a mass extinction. The abstract threat of a comet storm was now grounded in the horrific reality of a known world-ending event. Proving a single catastrophic event, however, is entirely different from proving a cyclical reign of terror. To validate the grand hypotheses of nemesis or a galactic rhythm, scientists needed to find evidence of a pattern of impacts, not just one. This has proven to be one of the most challenging and contentious quests in Earth science. Our planet is a geologically dynamic world. Its surface is a conveyor belt of creation and destruction. Plate tectonics consumes old seafloor. Volcanoes pave over ancient landscapes, and the tireless forces of wind and water erode even the greatest mountains to dust. Earth, unlike the Moon, relentlessly erases its own history. The terrestrial impact record is therefore woefully incomplete, heavily biased towards younger, larger craters that have managed to survive this geological assault. Despite this, scientists have painstakingly dated the known impact craters to see if their ages align with the 30-million-year pulse of extinction seen in the fossil record. The results have been tantalizingly ambiguous. Some complex statistical analyses have claimed to find a faint but persistent signal of a cycle, a ghostly rhythm in the timing of destruction. Yet, other, equally rigorous studies have dismissed these findings as statistical illusions, phantom patterns that flicker into existence only because the data set is so sparse and unevenly distributed through time. The evidence from Earth's own craters remains a heated debate, a whisper of a pattern that could be a profound clue or a mere coincidence. To escape the geological turmoil of our own planet, the investigation has naturally expanded to our silent celestial companion, the Moon. Devoid of an atmosphere, oceans, or active tectonics for billions of years, the Moon's surface acts as a pristine, perfectly preserved witness to the history of impacts in our neighborhood of the solar system. By using radiometric dating of the rock samples brought back by the Apollo missions and by meticulously counting and mapping craters with modern orbiters like NASA's Lunar Reconnaissance Orbiter, scientists can construct a far more reliable timeline of the bombardment rate. This lunar archive clearly shows the scars of the late heavy bombardment, an intense storm of impacts that saturated the inner solar system some 4 billion years ago. The crucial question is, what happened after this initial chaos subsided? Has the impact rate remained relatively constant, or has the Moon, and by extension the Earth, experienced periodic spikes or seasons of increased activity that would lend credence to a cyclical agitator? The debate rages on. The lunar data is vastly superior to Earth's, but it too is complex and subject to different interpretations. We have a clearer page from this silent archive, but the story written upon it remains a cosmic mystery we are still learning how to read. Thus, the painstaking investigation into the physical evidence arrives at an unsettling impasse. We possess an undeniable, definitive conviction for a single act of planetary murder. The Chicxulub crater and its global iridium layer are the tombstone of the dinosaurs and a stark, permanent warning to our own civilization. Yet, the evidence for a recurring serial offender, a hidden hand operating on a predictable schedule, remains frustratingly circumstantial, a ghost that haunts the statistical noise of an incomplete geological record. The scars on the Earth and the Moon tell us with chilling certainty what can happen, but they cannot definitively tell us why it happens or when it is destined to happen again. If the archives of the past are too degraded to provide a clear verdict, then the investigation must change tactics. The hunt must shift from the crime scene to the suspect. It must leave the dusty records of geology and return to the active, open expanse of the sky. The search for shadows must become a search for substance. The geological record of Earth and the cratered face of the Moon provide a stark and chilling warning. They are definitive proof that our solar system can be a violent place, and that catastrophic impacts are a fundamental part of our planet's history. Yet, the archives of rock and dust have taken us as far as they can. We It can firm the crime but cannot definitively identify the recurring perpetrator. The evidence for a predictable cycle of destruction, a key prediction of the grand agitator theories, remains tantalizingly ambiguous, a faint signal lost in the noise of an incomplete and time-weathered record. To solve this ultimate cosmic mystery, the investigation must therefore pivot away from the past and into the present. It must leave the dusty archives of geology and return its gaze to the active, open expanse of the sky. The search for the effects of these agitators must become a direct hunt for the agitators themselves. The hunt for shadows must become a search for substance. This new phase of the search is made possible by a profound technological revolution in astronomy. For most of human history, our view of the heavens was limited to what a single observer could see through a single telescope on a single night. Today we have built automated, robotic eyes of unprecedented power. These are the Great Sky Surveys, instruments designed not to stare intently at one object, but to scan the entire visible sky, night after night, with relentless precision. Observatories like Pan-STARRS in Hawaii and the Zwicky Transient Facility in California create a colossal digital movie of the cosmos, capturing billions of points of light and comparing them to images from the night before. Their primary strength lies in change detection. By subtracting one night's image from the previous, they can instantly identify anything that has moved, brightened, or faded. This is the perfect tool for hunting the faint, slow-moving wanderers of our own outer solar system, and this technological leap is about to culminate in the commissioning of the Vera C. Rubin Observatory in Chile, a behemoth that will photograph the entire southern sky every few nights with such depth and clarity that its 10-year survey will generate more data than all of astronomy that has come before it. We are no longer just looking at the sky, we are monitoring it. The primary target of this unprecedented observational campaign is the shadow that haunts the orbits of the outer solar system, Planet 9. A hunt for this hypothetical world is a monumental exercise in patience and computation. The strategy is simple in concept, but immensely difficult in practice. Astronomers use supercomputers to model the predicted orbit of Planet 9, identifying a vast swath of the sky where it is most likely to be hiding. Then they use these new wide-field telescopes to take deep images of that region over and over again. The challenge is sifting through the resulting data, which contains hundreds of millions of stars and distant galaxies, to find the one impossibly faint point of light that has moved. This is the modern equivalent of how Pluto was discovered, but instead of a human painstakingly comparing photographic plates, it is now powerful AI algorithms that search for the telltale shift. The difficulties are immense. Planet 9, if it exists, would be more than 10 times farther away than Neptune, making it extraordinarily dim, reflecting only a minuscule fraction of the Sun's distant light. Its orbital motion would be so slow that it would crawl across the sky at a glacial pace, making its movement difficult to confirm against the background stars. It is a search for a single, specific, dark grain of sand on a lightless beach the size of a continent. To date, despite years of dedicated searching, Planet 9 remains a ghost. But the Vera Rubin Observatory, with its unparalleled sensitivity, is considered our best hope. Within the next decade, it will likely either pinpoint the location of this hidden world or definitively prove that it does not exist, forcing us to find a new explanation for the strange harmonies at the edge of our solar system. But what if the agitator is not a dark planet, but a darker star? The Nemesis hypothesis, while faded, is not entirely untestable. While a brown dwarf would be nearly invisible to the human eye, it would still possess a faint heat signature, a ghostly glow in the infrared part of the spectrum. The Wide Field Infrared Survey Explorer, WISE, was a NASA space telescope that mapped the entire sky in infrared light, and one of its primary missions was to conduct a census of dim objects like brown dwarfs in the Sun's vicinity. The WISE data was meticulously analysed for any object with the slow looping motion characteristic of a companion in a vast orbit. The search came up empty. It definitively ruled out the existence of a Jupiter-sized or larger companion out to tens of thousands of astronomical units. While this was a major blow to the classic nemesis theory, it doesn't entirely close the book. An even smaller, colder or more distant object could still, in theory, evade detection. Furthermore, astronomers are employing other, more subtle techniques. The method of stellar occultation involves patiently monitoring the light from millions of distant stars, waiting for the brief, almost imperceptible wink that occurs when an object in our own solar system passes directly in front of one. This technique has been used with incredible success to discover the rings of distant objects and map the sizes of Kuiper Belt bodies. In principle, a large-scale occultation survey could one day detect an object in the Hills cloud, or even find a rogue planet drifting through the darkness. It is a search built on pure probability and the power of big data, listening for a single whisper in a galaxy of light. Beyond the search for light, whether reflected or emitted, lies the search for the purest and most fundamental signature of a hidden object. Its gravity, a massive, unseen world like Planet 9, would not just influence the orbits of tiny asteroids. Its gravitational pull, however faint, should leave a subtle but measurable fingerprint on the orbits of the known planets themselves, particularly the outer giants, Neptune and Uranus. Astronomers use what are called planetary ephemerides, ultra-high precision models of the solar system that can predict the positions of the planets with astonishing accuracy. These models are constantly refined by data from our most distant robotic probes, like the Cassini spacecraft during its long mission at Saturn. If there is a consistent, unexplained deviation in a planet's orbit, if it is not precisely where our models say it should be, it could be the gravitational tug of an unseen mass. This method is akin to feeling the presence of the planet rather than seeing it, searching for a ghost in the meticulous clockwork of the heavens. So far, no such definitive deviation has been confirmed, but our measurements become more precise with each passing year, and the gravitational whisper of a hidden world may yet be found within the data. Thus, the modern hunt is fully underway, deploying a breathtaking arsenal of technology and technique. We have built automated eyes to create a motion picture of the cosmos. We are sifting through petabytes of data with intelligent algorithms. We are listening for the faintest flickers of starlight, and we are measuring the positions of the planets with a precision that would have been unimaginable to previous generations. The search for the hidden agitators, for Planet 9 and the other phantoms of the outer dark, has reached its zenith. But as our technology pushes the boundaries of what we can see, it forces us to confront a new and even more profound question. The hunt is ongoing, but what if the most significant discoveries are waiting us at the edge of the solar system, and not about the hidden objects we might find, but about the nature of the boundary itself? What happens when our own robotic messengers, our lonely emissaries to the void, finally reach this ultimate frontier? What does the edge of reality look like, and what does it feel like to a machine that finally crosses it? The modern astronomical hunt for hidden worlds is a story of immense data and patient observation from afar, but there is another kind of exploration, a more direct and intimate one. While our telescopes peer into the darkness, we have also sent physical messengers, robotic emissaries launched decades ago on a journey that has far outlasted their original expectations. These probes are our hands and eyes in the void, providing a different and more visceral kind of truth than the faint, ancient light collected by our observatories. They are our first tentative steps into the interstellar ocean, and the data they send back from the threshold of this new reality is rewriting our understanding of what constitutes the edge of our solar system. They are no longer just exploring other worlds, they are exploring the very boundary of our own. Their names are Voyager 1 and Voyager 2. Launched in the late 1970s, they were designed for a grand tour of the outer planets, a mission of breathtaking ambition that took advantage of a rare planetary alignment to visit Jupiter, Saturn, Uranus and Neptune. Their discoveries transformed our vision of these distant worlds from simple points of light into complex, dynamic systems with swirling atmospheres, dozens of unique moons and intricate ring systems. But their mission did not end there. Built with a remarkable engineering foresight to survive the intense radiation and cold of deep space, they have continued to function for nearly half a century. As they journey ever outward, they have become our first true interstellar scouts. They are cultural artifacts as much as they are scientific instruments, each carrying a golden record, a gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. It is a message in a bottle, cast into the cosmic ocean, a greeting from a small blue world intended for any civilization that might one day find it. These silent, lonely machines carry the legacy of our curiosity into a realm no human creation has ever entered before. For decades, as the Voyagers traveled, they were flying through a familiar, if invisible, environment. They were inside the heliosphere. This is a colossal magnetic bubble, inflated by the constant supersonic stream of charged particles flowing out from our sun known as the solar wind. The heliosphere is the sun's sphere of energetic influence, a protective cocoon that pushes back against the raw galactic medium, deflecting a significant portion of the high-energy cosmic rays that bombard our solar system from distant supernovae and other violent cosmic events. This bubble is not a simple empty space. It has a structure. As the solar wind travels outward, it eventually collides with the plasma of interstellar space, creating a boundary region. The first part of this boundary is the termination shock, a turbulent frontier where the solar wind abruptly slows from supersonic to subsonic speeds. Beyond that lies a vast chaotic region called the heliosheath, where the solar wind is compressed and heated as it mixes with the interstellar medium. And at the very edge of this entire structure lies the final, definitive line, the heliopause. This is the tangible, measurable boundary where the pressure of our sun's solar wind is no longer strong enough to push back the galactic wind. It is the line where the sun's magnetic influence ends. It is the first edge of our solar system's reality. In August of 2012, after a 35-year journey, Voyager 1 made history. Its instruments registered a sudden, sharp, and persistent drop in the levels of particles originating from our Sun, and at the exact same time, a dramatic and sustained spike in the intensity of high-energy galactic cosmic rays. The data was unmistakable. After traveling more than 17 billion kilometers, the probe had finally punched through the heliopause. It had exited the magnetic bubble that had cradled it since its launch and had entered the raw, unfiltered environment of interstellar space. The weather it began to experience was no longer dictated by our sun. It was now feeling the energetic particles and magnetic fields of the wider galaxy. In 2018, its sibling Voyager 2 followed suit, crossing the boundary at a different location and providing a second crucial data point that has allowed us to begin mapping the true shape and nature of this immense magnetic shield. These were landmark moments in human exploration, the first time our creations had ever truly left the sun's energetic home and touched the void between the stars. Yet, this historic passage presents a profound and often misunderstood distinction. While the Voyager probes have officially left the heliosphere, the realm defined by the Sun's plasma and magnetic fields, they have most certainly not left the solar system. The Sun's influence extends in multiple overlapping layers, and its gravitational dominion is vastly larger than its magnetic one. The heliopause, the boundary that took the Voyagers decades to reach, lies at a distance of roughly 120 astronomical units. The Oort Cloud, the great sphere of comets held in place by the Sun's gravity, doesn't even begin for another 1,000 astronomical units at its very closest point. The Voyagers have crossed the first line of defense, the energetic border patrol, but they are still deep, deep within the Sun's gravitational kingdom. They would need to travel for another 300 years just to reach the inner edge of the Hills cloud, and for tens of thousands of years to pass through the Oort cloud entirely. By that time, their nuclear power sources will have long since decayed, and they will be nothing more than cold, silent, derelict ghosts, drifting through a realm they can no longer perceive. This reveals that there is no single, simple edge to our solar system. There is a series of nested boundaries, each defined by a different physical force. The Voyagers have crossed the threshold of the Sun's wind, a monumental achievement that has given us our first taste of interstellar reality. But ahead of them, still impossibly distant, lies the final and most profound frontier, the gravitational edge. The Oort cloud represents this ultimate boundary, a region of space bound to our Sun by the weakest threads of gravity, yet completely disconnected from its light, its heat, and its protective magnetic field. Our robotic emissaries have shown us what it is like to cross into the galactic medium, but they will fall silent long before they can tell us what it is like to exist in that ultimate twilight zone of existence. As we reach the final chapter of our journey, we are therefore left with the ultimate question, one that our machines cannot yet answer for us. What is the true nature of this final gravitational frontier? What does it mean to be a part of a system by gravity alone? And what does the existence of this vast ghostly sphere at the edge of everything truly say about our place and our reality in the cosmos? We stand now at the precipice of the ultimate question. Our journey has taken us from the familiar orbits of the planets to the chaotic realm of comets, from the ancient scars on our own world to the lonely paths of our most distant robotic probes. We have mapped the Oort cloud in theory, described its birth in violence and its eons spent in silence, and speculated on the hidden forces that may stir its depths. But what is it, truly, having crossed the boundary of the Sun's wind and stared into the vaster, more profound gravitational darkness that lies beyond? We must now ask what it means to exist on this final shore. What is the fundamental nature of this boundary, and can it truly be called the edge of our reality? A boundary is not merely a line, it is a zone of transformation. It is the place where one set of rules fades and another begins to take hold. The Oort cloud is the most profound and absolute boundary we know. An object adrift in its outermost layers exists in a state of near-perfect cosmic ambiguity. It is of the solar system, for it is still gravitationally bound to the Sun, a member of its impossibly distant family. Yet, it is also not of the solar system, for it is utterly disconnected from the Sun's light, its heat, its protective magnetic field, and the entire energetic reality that defines life and physics for the inner worlds. It is a place where the definition of home dissolves into a purely mathematical abstraction. Reality for any object is defined by the forces with which it interacts. Here, in this twilight realm, the primary interaction is a near-zero tug-of-war between the fading grip of a distant star and the rising tide of the galaxy. It is a place of pure potential, where an object's future is not determined by its past, but by the next infinitesimally small gravitational whisper that passes by. This is the edge of reality, because it is the edge of causality as we know it. It is the line where being a part of our solar system ceases to be a physical experience and becomes nothing more than a gravitational ghost story. In this sense, the Oort Cloud becomes more than a physical structure. It becomes a mirror, reflecting the limits of our own knowledge and the nature of our own consciousness, its profound and persistent mystery, its invisibility, its theoretical status, its dual role as a potential cradle of life-giving ingredients and a source of world-ending destruction makes it the perfect canvas onto which we project our greatest cosmic hopes and our deepest existential fears. It is the ultimate dark space on the map, where we as a species are compelled to write, "Here be dragons," or "Here be creators." We speculate about Planet 9 and Nemesis, about hidden alien artifacts and dormant microbial life, because the Oort Cloud represents the greatest and most immediate unknown that is still, by the thinnest of threads, connected to us. It is the physical manifestation of the boundary of human understanding, a constant, silent reminder that the universe within our own backyard is still largely a realm of pure imagination. And it is here, in this final act of contemplation, that we must confront the most unsettling and speculative thought experiment of all, the simulation hypothesis. If our perceived reality were in fact an incredibly advanced computational model, then the Oort Cloud is precisely the kind of structure one would expect to find at its edge. It is the perfect rendering boundary, a computationally cheap and elegant solution for creating the illusion of a vast populated outer system without needing to expend the resources to simulate its intricate details. Its properties are uncannily perfect for this purpose. We can infer its existence from the behavior of comets, meaning the simulation provides just enough data to make the system logically consistent. Yet, we cannot directly observe it, saving an immense amount of computational power. Our robotic probes, our most advanced explorers, are predicted to lose power and fall silent long before they can traverse it. A convenient and natural-feeling way to prevent a player from ever going out of bounds. This is not a claim that we live in a simulation. It is a recognition that the Oort Cloud's very nature, a ghostly, inferred and unreachable boundary, so perfectly aligns with the principles of efficient computation that it forces us to question the fundamental bedrock of the reality we perceive. In the end, our journey concludes where it began, with a sense of profound and humbling mystery. Whether the Oort Cloud is a primordial graveyard of creation, a loaded cosmic weapon awaiting a trigger, a metaphysical boundary between two states of being, or a line of code at the edge of a simulated world, its truest value lies in its power to compel us to ask these immense questions. It forces us to confront the scale of our own ignorance and the astonishing fragility of our own existence. It is the silent spherical monument that surrounds our tiny island of light and warmth, a constant reminder that we are encircled by an ocean of darkness whose depths we have only just begun to contemplate. We may never, in the lifetime of our species, physically stand on one of its frozen worlds or cross its full breadth, but the edge of our reality may not be a place we can ever reach. It may simply be a concept that will forever expand with the reach of our imagination. The search for the edge is, and always has been, the search for ourselves.